Good day, viewers. Today we are going to be deliberating on the topic integral. What we mean by integral is that integral is, we can also call integral the antiderivative, in the sense that when we differentiate what we have at the end of our differentiation, we can also integrate the answer to return back to the question. Example like for example, we know that the derivative of tan x with respect to x is equal to sec square x. You understand? So that is it. Then that means that the integral now of sec square x is, with respect to x, on the integral of this is equal to what? Tan x plus what? Plus c. When you integrate the equation, it bounces back to what we differentiate. That is what I'm trying to say. Then the derivative of sine x with respect to x is equal to what? Is cos x. Is cos x. That means that the integral of cos x is equal to what? Is equal to sine x plus c. Remember to always add plus c. Without plus c, the answer is wrong. Now, the derivative of the inverse, sine inverse of x with respect to x is equal to 1 all over what? Square root of 1 minus x squared. That means that when we integrate the answer that we have here, 1 into square root of 1 minus x squared, the x is equal to what? Is equal to this sine inverse of x plus c. Do you understand now? Then what if we have the derivative of exponential x with respect to x? Remember that the derivative of exponential x still remain exponential x, right? It still remain this. That means that the integral of exponential x with the x integral of this is still equal to what? Exponential x plus c. When you differentiate something, the answer that you have, when you integrate, you have the question now. One practical example is, let me use a number so that we can be able to understand what I'm saying. Okay, if y is equal to x squared now, or let me use any number. Let me use 4, a bigger number. For us to differentiate this, the y, the x is equal to what? Carry the power behind. Carry the power behind. That is 4. 4x, then minus 1 from the power. That is 3. That is how to differentiate. Now, let's integrate this. You see that I'll have this now. The integral of 4x cubed dx. Let's check whether we bounce back to this. I'll bring out my 4 outside, then the integral of 3 dx. Remember, you always bring the constant outside, then you integrate. Now, the integral, the formula for integration is what? If we check, it is always xm plus 1 divided by what? M plus 1. So that means that we are to add plus 1 to the power. That means that here becomes 4 into what? X3 plus. Okay, when we want to integrate, that is x raised to the power m plus 1. What is n here? N becomes what? 3. 3 plus 1 divided by what? Divided by 3 plus 1. So this becomes 4 into what? X raised to the power what? 4 divided by what? 4. This and this cancel. Remember that we have our x4 now. But I will add my plus c, because without plus c, our answer is wrong. So when we remember that now, we have been able to, if this and this cancel, it bounces back to this. That's what I mean, that the derivative of the integral, when we differentiate, when we integrate the answer that we have here, it bounces back to the equation. That is what I mean. You have been able to integrate this now, and it bounces back to the equation now, which is this. So that is important thing to note in integration. So you go back and list a lot of things. You list a lot of things and you differentiate. When you integrate, you have the equation. Another practical example is the derivative of this with respect to x is equal to what? Is equal to 1 minus 1 minus what? X squared. That means that the integral, when I want to integrate this, that is 1 into 1 minus x squared is equal to what? With respect to x, the x is equal to minus this plus c. So that is very, very important things for you to note in calculus. Okay, bye bye.